if I told you in this particular podcast we had to look for things that don't work? You'd probably go, what are you talking about? Yes, we're actually looking for something called non-permissible values, or as we like to affectionately know them as NPVs. These are values that don't work. So it's kind of like saying, okay, let's go looking for something that doesn't work so we know that it doesn't work so we don't go there. Yeah, that's basically what I'm saying. Watch. We're looking for any value for a variable that makes the expression invalid. Well, what do I mean by that? Well, surprisingly enough, we had non-permissible values in the last unit. We called them restrictions. We know that anything that's negative under a square root will not work, so it cannot be negative. Okay, so square roots cannot be negative. That does not work. So surprisingly enough, when we're looking for restrictions, we're actually looking for non-permissible values, NPVs. That's what we're looking for, okay? Take a look at this. When we're looking at a fraction, I could put any number I want up here, let's say like 15. But what can the denominator not be? Well, the denominator can never be 0. So you can never have a 0 as a denominator because guess what? That makes the expression invalid, and we basically say, don't go there. Okay, so that's what we're looking for. So when you think of non-permissible values, think of that, don't go there, because if you don't go there, those are non-permissible and we don't want to go there, and that just tells us don't go there. Know what I mean? Okay, here we go. So a non-permissible value in a rational expression, an NPV is any value that results in a denominator that is 0. So, okay, here's your textbook definition of everything. I'll let you pause the podcast right there and take a look at that one. But the whole idea is this idea of denominator being 0. That's what we don't want. Okay, so it's kind of a weird way of doing it. The weird way of doing it is figure out what makes the denominator 0 and then put a big, huge sign out saying, don't go there. Take a look at this rational expression we have here. So it says, determine all the non-permissible values. So we're not going to solve anything. We're not going to simplify anything. We're not going to do anything. All we want to do is figure out what are the NPVs. So it says right here, to determine any NPVs, set the denominator equal to 0, and then just solve it. Okay, so look, here's my denominator right here, 2x minus 6. I'm going to say, let that equal to 0. Or you could just turn around and say, let it say, you can't let that equal to 0, because if this thing down here becomes 0, you cannot divide by 0. You'd have x plus 4 over 0, and this thing would explode. Yeah, well, not necessarily explode, but that's invalid, doesn't work. So let's find out what does make that equal to 0. So simple algebra. Look, bring the 6 over, that becomes positive 6. Divide by 2, x cannot then equal to 3. That is your non-permissible value. Check it, prove it. If you put a 3 right here, right? Okay, 2 times 3 minus 6, 2 times 3 is 6, 6 minus 6 is equal to 0, and you know and I know you can't do that. So that's what a non-permissible value is all about. Okay, so let's look at some more complicated questions. I got 2 or 3 more down here that I want you to look at. I want to look at this one first. Okay, what do you do in a situation like this? Very, very simple. Remember, this is like having brackets here. This is like saying 2x times 4x minus 20. Well, guess what? If this is a 0, 0 times anything makes it a 0, and guess what? It doesn't work. If I made this here a 0, 0 times anything makes a 0, doesn't work. Okay, so what we have to do is we have to look at these guys separate. You will actually write down these guys separately. For example, you have 2x does not equal to 0, and 4x minus 20 cannot equal to 0, because any one of those two equals to 0, guess what? It's not going to work. All right, so divide by 2, x cannot equal to 0. Makes sense, because again, if this is 0, 0 times this, won't work. Let's solve the next one. This is 4x, cannot equal to, bring the 20 over, divide by 4, and you get x cannot equal to 5. There we go. So guess what? If you put a 5 here, 4 times 5 is 20. 20 minus 20, again, that equals to 0, and you can't have it. All right? So those are your two non-permissible values. And you can write them over here. You can see your NPVs for this is x cannot equal to 0 or to 5. Those are your two NPVs. And you'd list them off like this. What happens in a situation like this when you have a polynomial? Guess what? You got to factor it. Yep, PSA. And if you don't know what a PSA by now, folks, it's going to haunt you in this entire unit because this whole unit is all about factoring. And you got to be like incredibly liquid with factoring. If you're not, oh boy, I would say go see your teacher, get some factoring help. Okay, so two numbers together give us minus 12. Minus 4 and 3 work because minus 4 plus 3, of course, are your two that add up to -1. So your answers are -4 and 3. So what you would write out, you write this out in factored form, x minus 4, x plus 3. And remember, neither one of these can equal to 0 because if they do, guess what? Kaboom, it doesn't work. Okay, so that means x minus 4 can't equal to 0. That means x plus 3 cannot equal to 0. And you do them separate. X cannot equal to 4, and x cannot equal to minus 3. There's your two NPVs right there. You could try it. Put a 4 in here. Put a 4 here. Look, 4 squared is 16, right? Let me just clear this out a little bit here. 4 squared is 16. 16 minus 4 minus 12. Well, 16 minus 4 is 12. 12 minus 12 is 0. And that's basically saying, now you can't do that. You can't do that. That's not allowed. Same thing goes with minus 3. Let's try the minus 3. Look, if you put minus 3 in here, right? Minus 3, minus 3, minus 12. Okay? Oh, that's a minus minus, by the way. Minus minus. All right, so this is 9. Minus a minus makes it plus. Minus 12, look. 9 and 3 is 12. 12 minus 12, guess what? Equals to 0. So this is another one you can't have. It's just telling you if you put those values in, you're going to get a denominator of 0, and things aren't going to look very pretty. All right, let's keep on going to the last one. My personal favorite, which you can do two different ways if you remember the square root principle. Watch this one. This is x squared minus 9. You can say, oh, that can't equal to 0, but bring the 9 over. Guess what? That cannot equal to positive 9, square root, that means y cannot equal to, don't forget, the square root principle, plus or minus 3. Check this out though. You know and I know that becomes a difference of squares. Some people like doing it this way instead. Y minus 3, y plus 3 cannot equal to 0. And check out, this is where the difference of squares and the plus minus come from. Look, it comes from this. Y minus 3 cannot equal to 0. Y plus 3 cannot equal to 0. Look at that. Y cannot equal to positive 3 in this case, negative 3 in this case, plus or minus 3. That's where the square root principle comes from. Shazam, hey? Yeah, I know, it's kind of cool. So definitely look for things that are not permissible, because if you do, you get a denominator of 0, and you just can't have that.